everybody. Happy Friday. I am not able to be with you today, so I thought I would do a video lesson just to get us started and present a little bit of new information, but really just kind of practicing what we've been working with solving equations. So the icebreaker, I guess I'll say again at the end, is just to have a great weekend. So I hope your day is going great. We're going to get started. So today you've got this video lesson that is going to require you to have your note packet. So please go ahead and pause the video right now, but find your yellow note packet. And we are going to be starting on page 4. Okay, page 4, yellow note packet, lesson 2.2. So pause that and look for it if you don't have that out. Okay, so once we're done with this lesson, then you're going to have some practice time. There's going to be a few practice problems, and when you finish, you will be done for the day. So learning target 2.2, I can solve multi-step equations. We have been working this week on 2-step equations and really figuring out the reverse order of operations to help us solve for isolating our variable. So today we're just kind of adding on another step, another layer to it. So you're going to get some practice doing that. So here's just kind of some info. This is not on your note packet, but multi-step equations are going to combine things that we learned from our last unit, which was the distributive property and combining like terms. So we will be distributing today, which we did do some practice of that on Thursday. And then we're going to simplify by combining like terms. And then we will solve by using the reverse order of operations. So here is where we begin on page 4 of your notes. So please grab those notes. Notice that in that top box it says simplify first. So the first part of the notes that I want you to write in, right here it says combining like terms. Terms need to be on the same side. Can you please start by going ahead and writing in your notes right there is that our terms need to be on the same side. So terms are variables that are the same or numbers that are the same. So let's take a look at this first question. We're going to be using all the same strategies and steps that we have used prior. I'm going to move this up here. There we go. So the first thing that I'm looking at here is question number 1. You're going to notice that it looks very much the same, and we are going to use our same strategy. We are going to reverse our order of operation, but now we might just have to do with a couple things in the way. So first of all, I've got 8x minus 3x minus 10, which equals 20. So I'm going to go ahead and I'm going to put my line in by my equal sign so that I find the center to my equation. So there it is. It's balancing right now. And remember, our goal is to get the x all by itself. Well, right now, I've got a couple of x's. And notice how it says is that the terms need to be on the same side. So what we're going to do is my variable is the first thing that I'm trying to do, and I'm trying to isolate my variable. So what I'm going to do is I'm going to take this 8x minus 3x, and I'm going to underline them. Because if you remember when we combine like terms, these are in the same family. They both have the same variable. X is attached. So what I'm going to do is I'm going to put them together. I'm going to say 8x minus 3x. Together, that will give me 5x. Okay, so please write this on your notes. So I've got 5x minus 10, which is equal to 20. So all I did is I combined my x's together, and now they are combined. So I'm starting to simplify. Now, you might notice that this looks a lot like the problems that we've been solving this past week. I've got 5x minus 10 equals 20. So if we remember, when we're solving, we want to reverse the order of GEMDAS. And that tells me that when we're solving these equations, now that I've simplified my variables together, I'm going to start with the adding and subtracting operation. So the addition and subtraction equation or operations says that this minus 10 is something that we can work on getting rid of next. And so what I'm going to do is I'm going to use the inverse of subtracting 10. I'm going to add 10. When I add 10 to the left, I need to come over here and add 10 to the right. So now that I've got that on the left and the right, I am going to draw my teeter-totter. There's my teeter-totter. My teeter-totter says that we can now, check this out, my 10s eliminate. They are positive and negative 10. They are gone. So that's going to leave me with 5x equals, let's go ahead and combine 20 plus 10, which is 30. Now I'm getting to the bottom of my paper here. You have a bit more room, so I'm going to kind of squish this in, excuse that. But our last step here is I have 5 times x equals 30. So 5 times x, we don't really care what 5x. We want the x by itself. We want 1x. So reverse PEMDAS says now, step 2, we use the inverse of multiplying and dividing to help us isolate. So opposite of a multiplying by 5, I'm going to use the inverse, which is divide by 5 on the left, divide by 5 on the right. So now my 5 divided by 5 is 1. So that's going to turn into 1x, or just plain old x. And I'm just going to scoot my solution over here to the right. So I get x is equal to, and over here on the right, I'm going to say 30 divided by 5, which is 6. Now, the solution, when I plug it in, here we can check it to make sure that it makes sense. So I've got 8 times 6, which is 48. And I've got 3 times 6, which is 18. If I subtract that, I get 30. And if I subtract another 10, I get 20. So yes, awesome. 20 equals 20. It all checks. We are good. So question 1, the only extra step is that I had to combine the like terms over here on the left. Then I could do everything that I needed to do. All right, let's take a peek at question 2. So question 2, I've got 7 minus 2y minus 4 equals 13. So I need to solve to get my y all by itself. So let's start out how we've been beginning. Let's find our equal sign. And I'm going to draw a nice straight line to try to balance this out. We want to get that y by itself. So take a peek over here. I notice that on the left-hand side, I've got 3 different terms. I've got a 7, I've got a minus 2y, and a minus 4. Well, we can do a little bit of simplifying here first before we begin to solve, because I know this 7 and the minus 4 can actually be put into the same group. They're from the same family. So before I start my solving, I'm going to simplify first. So I'm going to go 7 minus 4 is 3. Now I can put my minus 2y in. So I've got 3 minus 2y, which is now equal to 13. So again, my first step there was just to kind of do kind of a little housekeeping by combining my like terms to the same side. If they're on the same side, I combine them by putting the 7 and the subtracting 4 together to get my 3. Now, I can go about my typical solving. Our goal is to get the y by itself. So again, I'm going to reverse PEMDAS, and here adding and subtracting is the first way to undo our operations. So I've got this 3, and I've got this multiplying by 2. That's what I have to undo to get to my y. So I'm going to start with a 3 because I can remove it by doing the inverse of adding 3. I'm going to subtract 3 from the left, subtract 3 from the right. Please draw your teeter-totter. My 3's then cancel, and that's exactly what we wanted. Now be careful with what's left over. Do you see what's left over? Not just a 2y, it's a negative 2y. That subtraction sign turned into a negative when I removed that 3. So negative 2y equals 13 minus 3, which is 10. So now we're almost there, but I still need to go another step because I want the y by itself. So keep in mind this is negative 2 times y. So to remove that multiplying by -2, I need to do the inverse of multiplying, which is dividing. Please use that division bar, the dividing fraction bar, to divide by -2 on the left. And come over here, divide by -2 on the right. Notice to get the y by itself, I had to divide both sides by -2, not just 2, the -2. So now -2 divided by -2 is 1 whole. And that's exactly the same as y, which is 1y or y. So again, I'm going to scoot my answer over here to the right. So I get y equals, now 10 divided by -2, a positive divided by negative is going to be a negative, and 10 divided by 2 is 5. So my solution here is -5. Okay, nice work. All right, moving on to our next question. So our next question, we are doing the same thing. So we want to solve by getting the d all by itself. So to help us find the center of our equation, to help it balance, let's go ahead and let's find our equal sign and let's put our line in. So there is my line. Now, we've got some work to do because I want you to notice that this is number 3, by the way. So on number 3, I've got 9d plus 4 minus 2d equals 32. Before I start my steps with solving, I need to combine some like terms. I want to simplify. I want to make this easier. So to do that, I'm going to take the 9d and the 2d, 9d, and the 2d. Now be careful because this 2d is a subtracting 2d. So we're going to think about that like a negative 2d. So 9d minus 2d's is going to give me 7d's. So there's my 7d's. Now this plus 4, I really can't do anything right now. I'm just going to report it right below. It doesn't have anything to combine with on the left-hand side, but I do know that this is all equal to the number 32. So now I have an equation that's going to look very similar to what we've been solving. We want to get the d all by itself. So to help us, we're going to reverse GEMDAS. So we start with our operations of adding and subtracting, multiplying and dividing, if there's any exponents, and then our grouping symbols. So remember, we're working through the reverse order of operations to help us come up with our solution and our final goal of d equals. That's what we want. So over here on the left-hand side, I see connected to my variable d is a multiplying by 7 and this adding 4. So what I need to do is I need to remove these in the order of adding and subtracting. So here, this addition plus 4, I can remove that by subtracting 4 on the left. And then I have to do the same thing on the right of my equation. Now I'm going to draw my teeter-totter. So there's my teeter-totter. Everything is balancing. And notice that my 4s here are going to eliminate. So I'm happy about that because those 4s are gone. So my 7 times d is going to now fall down, which is equal to 32 minus 4, which is 28. Okay, good. Now we're almost there. It looks like I just have one more step, and that step says, hey, I need to get this d all by itself. So to do that, I'm going to use the inverse operation of multiplication, which is dividing. Please use that division bar. So dividing by 7 on the left, we're going to use the fraction bar to help us. Divide by 7 on the right. And now we can go ahead and do a little bit of simplifying. 7 divided by 7 is 1, which is 1d or just d. That is equal to 28 divided by 7, which equals 4. Okay, so that one turned out to be a nice whole number. We could plug that in to make sure it's working. And we have solved our third one. On question 4, please come over to question 4. I'm going to find my equal sign, and I'm going to put my line in. Now, please notice that our variable over here is x. So this time my x is on the right-hand side. So when I'm solving, I'm going to have x equals, and this is going to go to the left because my variable x is on the right-hand side. So looking over here, I notice that I have 3 and I have a subtracting 4. Now they are in the same family. So what I'm going to do is I'm going to combine them. I'm going to go 3 minus 4, so 3 plus a negative 4. You can grab a calculator if you need to help check on that, but 3 take away 4 should give me a combination of negative 1. So here I've got negative 1 plus 8x. All of that is equal to 23. So now I've got this new equation and it's starting to simplify a little bit more. On the right-hand side, I've got 8 times x plus a negative 1. So again, we want to reverse PEMDAS, and I'm going to start with any addition or subtraction. I see this subtracting 1, this negative 1, and I'm going to reverse that. I'm going to add 1 on the right, which is going to add 1 on the left. Okay, again, I want to get that x all by itself, so I am undoing my operations to help me get there. So now my my 1's cancel, and I am left with 24 on the right. 23 plus 1 is 24, which is equal to 8 times x. So here, 8 times x equals 24. Gosh, I'm really liking my 8s and 24s on these examples. I didn't know how that would happen. So it looks like I've got one more step because I really don't care what 8x equals. I want that x by itself. So to get the x by itself, I'm going to do the opposite of multiplying. I'm going to divide by 8 on the right, divide by 8 on the left. 8 divided by 8 is 1. So I've got 1x, which is the same as x, and 24 divided by 8 is 3. So x equals 3 is my last one. So what we did on here is we were combining. We had to simplify first, then we were able to solve. All right, part 2 of our lesson. So I am at the bottom of page 4. It says distributing. So here we are going to now practice some distributing. And there's a couple of things that we want to put into our notes. So here it says for distributing, first, we want to distribute to each term blank the blank. Okay, so let's think what that means. So we want to distribute to each term in the parentheses. Okay, in the parentheses. So in the parentheses, we want to distribute to each term. Okay, so we want to share. So if you remember, I'm going to share the 6 with the x and the 6 with the 3. Okay, now not to be confused, this 5 right here, that's just problem 5. So that's not part of our question. Same thing with this number 6, that's not part of it. So what I'm going to do now is I'm going to distribute to each term in the parentheses. So I'm going to take this 6, I'm going to share it with the x, so I'm going to get a 6x. And then I'm going to take the 6 times the 3, that's an 18. So I'm going to do a plus 18 because there's a plus sign in there. All of that equals 40. Okay, so here what I did was I distributed my 6 to the x and my 6 to the 3. So I distributed each term in the parentheses. Now, the second part says, as necessary, combine like terms. That's what we're going to do. But if you look here, there's no terms to combine on the left or the right, so we're just going to solve. So that's why it says, as necessary, combine like terms. Can you go ahead and add that in your notes? Like, add terms. So you might recognize this equation as something that we've been solving all week. Once we shared the 6 to the x and to the 3, we can now go ahead and solve. So I'm going to reverse my GEMDAS. I'm going to start with my adding and subtracting operations. And I see that here this is 6 times x plus 18. So I'm going to unwind or undo by doing a subtracting 18 on the left and on the right. Please draw your teeter-totter. There's my teeter-totter. So my 18s They cancel out because a positive and negative are the same. So they are 0, which is now 6 times x equals 40 minus 18. I have a 2 right here and a 2 right here. So 6. I just want to make sure I did all that really quickly. Yep, 22. Now, this question is going to turn out to be a little bit different. We haven't done a lot of these, so I'm so glad we're getting it in our notes. So 6 times x equals 22. Well, we could really think about this for a long time, but we're not going to get a nice whole answer because it's going to be a fraction or decimal. So we're going to continue to do our problem here by getting the x all by itself. To get rid of this times 6, I'm going to divide by 6 on the left. Then I'm going to divide by 6 on the right. So 6 divided by 6 is my 1, which is good because I wanted my x all by itself. But check this out. I've got 22 divided by 6. Now remember, this division is also a fraction bar. So 22/6 is the same as 22 over 6, which is an improper fraction. We can actually reduce that. Remember, 22 over 6 can be reduced. I can divide by 2 on the top, divide by 2 on the bottom. I'm reducing my fractions here. So that turns out to be 11 over 3. So I'm just going to circle this big old thing. It is an improper fraction where my solution is 11/3. Now, if you want, we could change that to a mixed number. I know that 3 goes into 11 3 full times because 3 times 3 is 9. So this, I could put a little equal sign here, and I'm just making this, it's kind of a mixed number. 3 goes into 11 3 whole times with 2 leftovers out of 3. Some of you might want to write it as a decimal, which would be 3.33333 repeating, which sometimes is hard to work with repeating decimals. So that one definitely was a little bit more challenging because of how it ended, and showing our work helped us get that fraction in there. So it would be completely okay to leave your answer as 11 over 3 or 3 2/3. Now, the last problem here, I am going to find my equal sign and put my line in. And here's what I notice. I notice that I've got some things going on over here on the left. I've got these parentheses, and it is a grouping symbol. So in order for me to even get that grouping symbol taken care of, I'm going to have to distribute. That grouping symbol here, x minus 2, I don't know what that is, and there's nothing to do inside. So what I'm going to have to do is I'm going to take this 5, and I'm going to share it with the x, and then I'm going to take the 5, and I'm going to share it with my 2. So I'm going to have to distribute first, and then do some combining to get my solving done. So 5 times x is going to give me 5x. 5 times 2 is a 10. Now, I know it's going to be a negative 10 or a subtracting 10 because of the subtraction sign, so I'm going to squeeze that in. Now, don't forget, here is my plus 4x. And I think what I'm going to need to do here is I'm going to need to scoot my line over just a little bit. Oh, I guess I couldn't do that. It didn't want me to do that here. So I'm going to go back to my pen. But here, oh goodness, I don't know what I did. My whole problem got erased. Oh, it went down like that. Oopsies. Oh, there. Okay, sorry about that. My slideshow shifted a little bit. So I've got my 5x minus 10 plus 4x. So that's what I want, my 4x to squeeze in there. All of that is to equal 8. I was just trying to shift my work over a little bit, and that didn't work so well for me. Oh, well, we got this. So now 5x minus 10 plus 4x equals 8. So I need to combine some like terms over here, don't I? Do you see this 5x? Do you see this plus 4x? Let's put those together to give us 9x's. So I've got 9x's minus 10, which equals 8. There it is. Okay, so now we are sitting where we are comfortable. We've been working on two-step equations. I'm going to reverse GEMDAS, and I've got 9 times x minus 10 equals 8. So I'm going to go with the subtraction by doing adding 10 on the left and adding 10 on the right. I'm going to draw my teeter-totter, and my 10s are going to cancel. So now I have my 9 times x equals 18. Oh, we are getting so close here, so close to the finish line. So let's go ahead and get rid of this times 9 because I want that x all by itself. So I'm going to undo by dividing by 9 on the left, dividing by 9 on the right. 9 divided by 9 is 1, or just my plain old x. And I've got x equals 18 divided by 9, which is 2. Wow. Thank you so much for holding in there with me. We have finished page 4. So we just did 6 questions that are pretty challenging. Okay, they're pretty challenging. So what I want to do is I'm going to clear this. I'm going to take a peek. And here, again, we're going to skip the rest of those. But it said, you did a good job. False. You did an awesome job. Okay, so there is Dwight, and he says that you did an awesome job. Yes, you did. So right now, I have some practice problems that I want you to try for Monday. They're level 1 and level 2, so go ahead and put your name on the top. Okay, you are going to get your practice problems, and what I want you to do is you are going to be solving. You're going to combine like terms and then solve your equation. Okay, so there's 6 level 1s and there's 4 level 2s. Okay, and then you are done. I'm going to leave some hints on the student resource page. So remember to get to your student resource page, you go into Classroom and you can find those hints in there. If you get stuck, those will help you out. All right, have an awesome weekend, and I will see you on Monday. Bye.